Hello everyone. So let's see what is the today's problem is. The today's problem is that we need to find out if the number is prime or not. Before solving this question, let's go to the screen and check what is the prime number is. So prime number is this kind of number which have only two factors. That means the number is only divisible by 1 and the number itself. So let's take an example. Like if I take 3, 3 has two factors 1 and 3. That means 3 is only divisible by 1 and 3 itself. If I take another example, 5, 5 is only divisible by 1 and 5. That means it also has two factors. So if the number has two factors, and then we called it prime. But number 9, is it a prime number? No, because number 9 is divisible by 1, 3 and 9. That means number 9 has three factors. So it is not possible. So let's go to the screen and try the code. Here the first line, in the first line they have given the t. T is number of test cases, that how many times we want to check the number is prime or not. This is the number of test cases. So let's try to code it. At first create a scanner class for taking the input. Scanner scn is equal to new scanner system dot in, right? Next take the test case t is equal to scn dot next int. Now run a loop while t is greater than 0, and for terminating the loop we are using t minus minus. What is happening here? Let's see. If the t is 3, that means 3 is greater than 0. It comes inside the loop, and now t's values is decreases to 2. 2 is greater than equal to 0. Yes, 2 is greater than equal to 0. So it's come back again, come inside even. Sorry, not come back. It come inside the loop and change the value 2 to 1 and check it again. 1 is greater than yes. Then change it 0. So this way the loop work here. Now take the number as input. So for taking the number as input, int n is equal to scn dot next int. For storing the factors, we using count is equal to 0. Firstly, there is no factor, as we have not checked it yet that this number has how many factors. So firstly the factors is 0. Now create a loop till 1 to till n and check the number has how many factors. If for finding factors, what we will do, we will use modulo operator. So n modulo I equals to 0. That means it is totally divisible. So now we increase the value of count, and outside the loop check if the count value is 2 or not. If the count equals to 2, that means it is a prime number. System dot out dot println, this is a prime number. Yes, it is not a prime number. Dot out dot println, not prime, right? Now check it out. I will get some error because I put here small I, so I need to change it. If I change, now run it. Here you can see it is showing accepted, but if I hit on the submit button, it will throw some error. What is the error? Is basically the error is it is a time limit exceeded error. What is time limit exceeded error? Let's see. What is the time limit exceeded error? That means your code is taking too much time to execute. That's why it's throw you time limit exceed error. So let's take all the input. Here you can see, sorry, not take the input. Here see. I is less than equal to 2, less than equal to 1000. That means the t's value vary from 1 to 10 to the power 4 and n values varies from 2 to 10 to the power 9. So let's check the what is the time complexity is here. Actually 10 to the power 9 means 1 second. If your code take 10 to the power 9 second, that means it is 1 second or less than 1 second. This is the good time. This is the good time complexity. This is the good time complexity, because if your code execute less than 1 second, that this is more faster than 10 to the power 12 or 10 to the power 13. We want every program to run less than 10 to the power 9 or 10 to the power 9 second, because we want the first time, we want fast work. That's why it is. Now check what we can do in this code. So now check what is happening in the code, that it is taking too much time. So I will cut the code from here. Sorry. I will cut the code from here and go to the page. Now check. In the first line, when the while loop is running, in the first line, when the while loop is running, it's taking 10 to the power 4 times to execute, and in the next line, when the for loop is running, it's taking 10 to the power 9 times to execute. So total number of operation is happening here. This is 10 to the power 9 into 10 to the power 4. That means 10 to the power, that means 10 to the power 13. So here you can see that is the time limit is too much. That's why it's throwing the error that your program time limit is exceeded. So now check how we can improve this code. So let's take some numbers like 36 and 24 and find out all the factors of 24 and 36. Factors of 24, 1 into 24, 2 into 12, then 4 into 9. Sorry, not 4 into 9. It will take it one more again. Take it again. 1 into 24, 2 into 12, 3 into 8, 4 into 6, 6 into 4, 8 into 3, 12 into 2, 24 into 1. Let's take the 36 and find out all the factors. 1 into 36, 2 into 18, 3 into 12, 4 into 9, 6 into 6, 9 into 4, 12 into 3, 18 into 2, 36 into 1. Have you seen here that the root over of n, after the root over of n, all the factors are still remain same. If I find the root of 36, that is 6. So after the 6, here you can see all the factors are still remain same. And in this case also, root over 24 is something 4.52 or something this way. So after root over, all the numbers are repeating. So what we can do in this code? We are running from 1 to till n, but now what we will do, we will run from 2 to root over of n times, because if the number is divisible by 2 to the power root n, then it will must divisible by after the root n also. If it is not divisible root n, then it will not divisible after the root n also. So let's see what I am trying to say. If a and b is equal to root n, that means a's value cannot be greater than root n, b's value cannot be greater than root n. Means if we take a number like 36, 6 and 6, it is a, it is b. Here you can see root over n is 6, root over n is also 6, and a is also 6, b is also 6. Is a is greater than root n? No. A is not greater than root n. B is also not greater than root n. So what I am trying to say, if the number is not divisible still root n, that means it will not be divisible after the root n. That's why we are trying to change in the code that we will run it from 2 to I square means I square root n means I square less than equal to n means I less than root over n. So if these things is happening, that means, so after that, if the count is equal to 0, that means it is prime or it is not prime. What we can do here more, that if we find out any factors, that means it is not prime. So we will break from the loop and print out that it is the not prime number. So let's submit it and check it now. Here you can see it is giving me correct answer. So now understand what is happening here. That I will take a number like 9, and what is the root over of 9? That is 3. So the loop will run till 2 to 3. That means the loop will execute for 2 and 3. And check it here. 9 modulo 3, 9 modulo 2 equals to 0. No, that means the count will still remain 0. Then it check again. 9 modulo 3 equals to 0. Yes, 9 modulo 3 equals to 0. That means counts is equal to 1. So here we can see when the counts becomes increased, that means it is not a prime number. So we will break out from the loop and print out that it is a not prime number. If the counter still remains 0, that means it is a prime number, and we will come back here and print that it is a prime number. So this was the question. I hope all of you understand the question and also the answer. So thank you.